So another patient monitor teardown. This is a ProPaq 106EL, just another little similar widget. Apparently the display on that previous one, the general consensus seems to be that it's a planar electroluminescent display. And looking into the display on this one, it sure looks like it's pretty damn much the same thing. This one is kind of interesting. You can see the, it's got this kind of rubber pushy switch, defib sync. I guess that's so that it can talk to a defibrillator somehow. Some sort of external monitor, battery charging. You can see it's got a big ass section back here for a battery, and then this huge port, probably for debugging or something. And then we've just got cuff vent. They say do not block, and yet it's threaded so that you can stick something in there, whatever. NIBP, P1, P2, and ECG. So, very similar to the other one. Let's see. Looks like it's just got 4 big Phillips screws holding it together. Actually, this one also, I'm not sure, it may be metal. This is definitely metal because you can see the wear on the edge. It's intended to like hang over the bar on a bed or something like that. Apparently it was made in the USA. It's another one to the people. The guy telling me on the last video I need to, you know, sanitize them. I would if I could. Or I just don't have any of the real proper tools. So what I just do is I just scrub the crap. I just, you know, scrub all the way down to my elbows with some antibacterial soap, antimicrobial soap afterwards. And then I swab my bench with a bleach-based cleaner. And hope. See, 4 screws. Pretty durable sucker. So I'm going to do what I did on the other one, which is I'm going to just take it apart far enough to try and power it up, have it poke around, and then do a complete teardown. Power on this one's pretty obvious. Obviously this is the power connection, but it looks like there's 3 terminals. I bet it's like the previous one where there's, you know, basically ground, battery, and oh, that's kind of disgusting. There's like goo. Where is my anyways, so we can start to see all sorts of fun stuff. Lots of connectors. So there's the pump for the blood pressure. That's interesting, so you can see that here's the transducer. So they've got, look at all these elbows. So that is the NIBP transducer, the pressure transducer. And then so it looks like so power supply's on the back, all the analog stuff is on the front. So nice keyed connectors. Everything is a different size too, it looks like, which is, what is it? Yeah, they're all different pin counts. So here is the actual like analog section, if you will. And you don't see a clear isolation barrier, but I'll get there. Oh wait, yeah I do. It's this groove. So this groove here, along here, optos, and then up there. So this is probably a medical grade DC to DC. Multi-comp. Lots of chips. This one's a little later, and you know, later generation, you can tell because it's all surface mount. Anyways. So here is the back. So we have pumps. I don't know what that is. There's a pneumatic valve. This could be another pressure transducer. Just has like a little thing in here. So these are These are actually the connections for the patient leads. Whereas over here we have power and more isolation. Look, there's a little row of optos right down there. Actually, it kind of looks like two of these pins are ground. Yeah, actually, let me... Let's see, so we're in continuity mode. Yeah, that's interesting. So those two pins are grounded, and then this is power. So it's a 3-pin connector, but they're only really using 2 pins. Well, that's strange. Anyways, now that I've ascertained that much, I know the pin out. I can infer the pin out from what I just saw. Let's plug it back together real quickly and power this fucker up. See what it does. One thing of interest is that the supply range on this is very broad. It's 12 to 28 volts. Also, the battery charging mechanism, whatever it is built in, unlike the previous system, which brought the batteries out to an external connector. Let's see, where is that? All right. So I think I will just use my test probes. Let's come up. Let's go for 24 volts. Lots of current. Oh. Oh, hey, I see a light. And it's drawing 50 milliamps. Oh, now it's drawing a lot more. Hey. Whoops. Lead cables. Ah, fuck, I can't hold the probes in very well. Battery, 9.4 volts. 1988 to 1995, so this is probably 1995. ECG fault. So, not... Oh, bother. I need a better way to power this. Let's see, do any of these little... This thing takes huge diameter pins. You can see there's the little battery charging light. Alright, much better. Orbital System Incorporated, ProPaq 106. Same type of display. Oh, hey, look, you can also see the scan line. So, display, wave cell, cuff off, next, main menu, sensors, cuff. Kinko's, check out, that's pretty funny. This one's a little more sensible. System, more, and serve, Oh, hey, it's like a simulation mode. That's cool. So you can kind of see. Not zeroed, not zeroed. 0P1. 0P2. 121/79. Huh. More. So I wonder if P1 and P2 are like invasive blood pressure measurement things, because they both look like that. Though this one's 25/9 and that one's 21/79. I don't know. Oh, I think somebody's gone into cardiac arrest. Or something. Let's see, trend. Temperature, heart rate, P1 millimeters, Hg, millimeter Hg. So let's so I'm betting this is has produced in 1995. So it's set to alarm on heart rate and the cuff. Stat set. Oh, hey, that's interesting. It's got like an alarms off thing. Oh, hey, heart rate. Oh, I see. So it was 125, so it was just going over that. Next. Param off. More. On, off. More. On, off. Alright. I wonder what freeze does. System. Time, day. Oh, hey, I could say. I don't know. It's correct. It's for the wrong time zone. Yeah, INV-PRS, invasive pressure. Or intravenous pressure. I like the keys on this. They're nice and clunky. It's not like the membrane keypad like the other one, though I bet the membrane keypad's a hell of a lot easier to sterilize. System. It's funny that like you go to system and then there's just back and then actual system. Program. Default current. Save current settings. Day. More. Change next service. Not intended for patient use. Are you sure? Jesus Christ, that's loud. Oh, hey, look at that. Pressure 2380 counts. Pump time 3 seconds. I don't know what the OS signal is. I wish I had a cuff. So it's labeled IBP. So that's what P1 and P2 are, I guess. Well. So leak rate, that's interesting. So I guess this pumps the cuff up and then just lets it sit. I don't have anything I could use. Oh, it's got to be reset before I can do anything interesting. So I was just kind of gradually making, blocking it more and more. How did it know that? I don't know how long it normally takes to fill up. Yeah, I can't really fake it that well just using my finger on the little hose nipple down here. But anyways, that's kind of interesting. I wish I had a test lead set, but I'd probably wind up hurting myself with it. Cool, so let's, now that we've taken a look at the functions, let's take a look on the inside. Wait. Some connectors. So I would bet that this here, so well I know that these are the various leads for the test things. This I would bet is for the blood pressure cuff, and then these are probably power and all the other assorted stuff. Because if we look back here, you can see these are going to, basically the power section. This lead, which seems to run down here, I think is for the, basically the blood pressure cuff. And then these three leads here, which you can see go through this giant ass ferrite and down in there, are going to the electrodes. You can also see all of this. They've kind of got a similar, ridiculously complicated, kind of set of hoses down here. Much like the other one. I don't know why it's so complex. I don't know what this is. This is kind of interesting. Big stainless steel. That's obviously a valve. And then we have what looks a hell of a lot like a DC to DC with a big isolation barrier here. And then there's a transformer. I would think a lot of this, I don't know why they've got all this isolation here, because I don't see the isolation gap from these digital isolators carry. Oh wait, yeah I do. So it goes up here and then wraps around to there. So this section here is isolated, and this is actually a transformer. So that's really interesting, because it looks like, so the main power comes in on this connector here, I think. Actually, it runs up under there, and then I think it comes, I actually don't know, but you can see there's a giant little wound inductor up here. I don't actually know where the actual power leads join the piece circuit, the traces, but this appears to be the battery connections, I think. Could actually be power, and then they come in down over here, and then there's this big transformer isolation here. Then you've got another DC to DC up here, and there's this connector here which goes off into this ribbon cable, which I bet feeds the LCD. So I think the connection for the LCD may go through this board here, which is kind of a little ridiculous, but what have you. So there's lots of stuff in here. This chip here is, well, it's a LT1170. It's like a 5-pin TO220. Lots of big caps. Down there we have a TLC 27L9C. I don't know exactly what that is, but I think it's an op amp. But you can notice it looks like there's actually a pressure transducer down here as well. Or something, and that may just be a pressure switch. Here's that solenoid valve. There's a little, so down here there's a TO2 package that's marked D18. That's probably, you know what, no, I think the power actually comes in here. I think this is the power input. And then this is the main power transformer. Yeah, and then I think the battery connections joined actually are down here. And this little fiber sheet is in there for some reason. Okay, I'm going to have to take this board out just because I'm too curious as to what's beneath it. Where are you, screws? So I think the power switch is actually like a soft power switch, because you can see that I think the power comes in here, and yet the power switch is on this side. Actually, there's an easy way to check that. So my meter is on diode check mode. And let's just go to this ground here and this ground here. So that is either there or there. Oh, whoops. Yeah. Okay, so that's a 3-pin connector, and they're just not using the 3rd pin. So it appears that the power comes into this corner here, and then this is it's a UC3846DW, and then we have 2 big transistors here. So this looks like the same, kind of the driven with the center tap, driving system from the previous one, and then it goes through this interesting pot core transformer. But not only is it a pot core transformer, it's a really, really, really tall pot core transformer. That's like an inch tall, made by Z Magnetics. It's a very unusual transformer. So if there's another screw down in this corner, I'm going to be really irritated. There's another screw down in this corner. Fuck you. Oy. That is not an easy screw to get to. It is way down in here. Assholes. So the whine, I wonder if that's all in the motor or if they're pulse width modulating, driving the motor, and we're just hearing magnetostriction for that horrible whine when the BT is running. So that has to be disconnected. I'm going to have to pull that. It's not easy to get to. I really like these connectors. Did I get that totally loose? There's that screw in there. No, I didn't. Just now I can get to the screw to remove it. Ah! Ah! There it goes. Probably damaged some of the parts on that board. So. What is all of this hose? Oh, it's caught. Oh, I see. So this filter is in series with the input, it looks like. Wow, that's hack. That's a hack. That's interesting. Look at this. It seems like sections of this tubing are black on the inside. Is there a tube in there, or is it just filthy from pulling in Lord knows what out of the blood pressure cuffs? Oh, and there's a whole bunch of power transistors on the bottom of this board. That's fairly intriguing. Okay, so let me see. That disconnects there. So that is just going to the vent, so they've just got a little inline filter. And then this is going to the blood pressure cuff. Is that fluid in there? No, it's just gunk on the tube. Okay. So, this is fairly busy. What is this giant ribbon cable? So there's this several big ribbon cables. Oh, of course, it's all of this stuff. So it's the defib sync and that. So most of that's what all of this stuff is. And then this is just the power switch and then 2 leads. And then here's the actual power input. So it's definitely secondary side switched. And then these connections here, I'm not sure. Some of them are definitely the battery, but some of them also seem to run up into this corner. Oh, it's the battery charging light, I bet. So I think some of these connections on this, 2 of these go to the battery and 2 of them go to the charging light. Actually, that takes 12 volts. I don't know. Interesting. Anyways, or that could be. You know, another thing of interest is you see this connector. I'm pretty sure that this down here is a thermistor for the battery, because this takes a lithium battery. Oh, and I bet it's also this huge connector here, which is so that's what all of this is. Mysterious connectors of mysteriousness. And you can see here this giant white box that's got epoxy on the back is the temperature plug. So I guess that's hermetically sealed. Strange. Anyways. Cold beverage. So this is here. We have this funny little baffle solenoid. So we can see that there's just 2 leads here for this interesting blocky assembly, which just has 2 connections. Okay, so that goes to the output, and this goes to the input. Is it possible that this is like a controllable solenoid valve? It could be like an analog valve. I can see that. So anyways, down here, power input right there. Just 2 leads. There's a third lead there, but it's not, but it has a trace. There's a trace that runs into some of the circuitry here. One of the things you can see is this is a 4-layer board at least. It's also, look at that, and we've got a capacitor, there's like a Z cap, and then there's a neon labeled LP1. So here's the switch mode controller. You've got 4 optos, because again, remember, this is it's soft switched, because it's switching the power transformer somehow with something on the secondary right over here. So then you've got, this huge power transformer, this extremely tall pot core transformer. There's a big diode right there. That's going to be the output rectification, I believe. These are probably snubbers across the diode. Over here we have the 2 power transistors, which are free-floating TO220 IRF 540s. Big power FETs. The optos are as an NEC 2501, 2501, 25. Wow, these are just 2501. Just totally bog standard. This is an S12MDI1V or SM12 or S12MDIV by Sharp. So these are just totally bog standard, but this isn't. We've got a bunch of adjustment pots, which is interesting. This is another power transistor, or, excuse me, another power transformer. They're all made by the same company, Z-Man Magnetics. Intriguing. It's also worth noting that this apparently has 2 primaries and 2 secondaries. Because if you look at the bottom, you can see you have the 3 primary, there's 3, and then there's these 2 here, which run up. Because you can see they just kind of run up into the sheath. I wonder what that is. And the whole thing's been, you know, epoxy filled. So here is the main. There's the pump, and then there's another little. What is that? It is an MC132A down here, and then actually, interestingly enough, there's a multi-turn pot, and then there's a whole bunch of power devices on the bottom, which are probably for switching the solenoid valves. These are all Q1, Q3, 15N06, 948 is, so it's 948 Motorola logo, new line 15, new line N06V. And then there's some other stuff over here, and then this is a MM74HC4060. And this whole thing is protocol systems, Rev D. And then there's just a bunch of various surface mount passives. There's a whole boatload of caps. Are those all in parallel? Yep. So they needed some really low impedance ceramic caps. That's probably on the output of this switch mode system. You know, there's a couple diodes there. So this may be generating the backlight for the EL display or something along those lines. And it's all kind of silicone down. So anyways, that's quite interesting. And then you can see they've got big bolts and various big chunky hardware holding this down. And then if I grab my light, you can see that the isolation barrier is along here. So that's not Look right there, they've kind of got a trace going across the isolation barrier. Though I guess they're just relying on the fact that the punch-through voltage is much higher than the voltage across the surface, so that they've got plenty of clearance. Seems kind of janky. And then they've also got 200K resistors in series bridging the isolation barrier. So 200K. That's kind of funky. Yeah, 1003. So they've just got a little, an isolation barrier bridge right there. Let me switch lenses. So here we are back on the bottom side. You can see there's the 74HC4060. Here are these power devices, 15N06V, a whole bunch of them. Big screws. You can see down here, Protocol Systems Incorporated, Rev D, fab number. So here is this, you can see they've got 2 resistors in series bridging the isolation. Then here you can see this this trace poking out into the isolation gap, which seems like kind of bad practice. And then there's all of those giant capacitors, or all the ceramic caps in series. Not much else on this side of the board. Lots of little passives and rectilinear layouts. And then over here, so there's that main chip. UC3846DW, and there's all the optos, S12MDIV or MD1V. The other ones are just NEC2501s. Little adjustment pots, little tiny surface mount parts. Oh, hang on, there's another, some sort of SOIC part down there that I can't make out. Oh, they're 431AC. Is that an LM431, that little voltage? Really? Huh. Yeah, they're the same part. Weird. Lots of analog stuff going on down here. So these are the 431 ACs. Those are programmable voltage references. So they're probably using those in the optos as like an air amp somehow. You can see here's the Z-Man magnetics. Lots of diodes down there. Here's this control IC, which is an LT1170. I bet that's a switch mode with integrated switch. There's that big D18. The power switch is just connected right here, and then there's a little, hey look, there's a 3 amp fuse, F2. I wonder what, Over here we just have some, there's that TLC 227L9C. Hey look, recharger. I guess the recharger's somewhere in here. Here's this interesting device here, PT1. What does that say down there? PT1 ALT. Oh, I guess they have two different devices they can put down there. It certainly looks like it has several footprints that can fit there. So PT makes me think pressure transducer. It's also got 4 leads. Actually, that's an interesting. So this actually has snaps. So I'm stabbing myself. Oh, that came loose. Cool. There it goes. Oh, I broke it. I broke the snap. Alright, I guess I'm not putting this back together. But you can see that it appears that there's some sort of diaphragm that's a rubber membrane. I think this is a pressure transducer as well. So this is some sort of mechanism where this is the actual sensor. And then there's probably some interesting stuff in there. And then this is kind of a little... I would bet that this is just, you can kind of see how there's just a hole there that sits on that gasket. It's probably like I think this predates MEMS. This bastard solenoid is in the way. So I couldn't get that loose. But yeah, so that would just kind of sit on there and seal. And that was how it worked. Alright, now that I've broken some of the parts, I guess I'm gonna not worry about putting it back together entirely, which is certainly somewhat nice. Anyways, moving on. Put the screwdriver bits. So here is the actual, here's kind of the board with the, this is the microprocessor board. You can start to see that we've got several various flashes, more isolation. You can see here this is, so there's 2 flashes. There's this one, and then here's the isolation barrier, PC900V, 2501, PC900V. So I bet this is like serial over the isolation barrier. There is the little isolation. That may be a transformer. And then here's another flash. And I bet the micro is down in here somewhere. Let me get this brace off. Actually, let me change lenses again. So here we are. This appears to be part of the clamping assembly. Oh, long screws. I need a bigger screwdriver. There we go, thread locker. Oh wow, look at that. It's all precision machined to clamp around the parts. Fancy pants. Also, look at that. It's got like a surface texture. This is... I bet this is just like... I wonder where the hell they bought this. Looks like it's intended for facades or something. So, we have flash. I think this is just a transformer. Possibly, I'm not sure. But anyways, this is probably the main CPU. All the devices, all this stuff. I bet this is part of the display driver. It's a Hitachi part. Here's another. Yeah, actually look at that. These are the same part, I think. So this is probably program memory and flash. And then some of this is probably SRAM or something along those lines. I'll get in closer. We've got There's the battery back for the RTC, which I bet is in here somewhere. And then you can see over here we've got big metal shielding cans over the whole analog section. And then there is a couple screws holding this in, as well as that interesting bracket assembly. I guess they were really tight for space. So that's interesting. And actually, oh wait, look, that's an HC49U crystal folded up on edge and soldered down. Wow, they were really tight for board space on this sucker. I have this connector here, which I'd bet just goes to those two LEDs on the front. And then now that all those screws are out, except for that one apparently, oops, there are my tweezers. All the screws are out, this board just comes right out. Oh hey. And then there is it's not soldered in, it's just stuck into sockets mounted into the PC board, which I now bent the crap out of. Yeah, so this ribbon cable here is everything for the LCD. And I forgot to put the lid on the ISO again. So this is interesting, look at that, we've got another shield, another PC board, you know, a very thin 0.016 FR4 PCB back here for shielding. That's kind of a funky shielding mechanism. And you can also see here that we have sockets inserted into the PCB, which is what the, so these two ribbon cables here I bet are for the buttons, which look to be, wow, well no, I don't know what that's for, actually. Because if you look, you can see that the buttons, the clunky buttons, actually just have PCB pads. So, this is very strange. Could this be more data going into the display? Yeah, I guess it is. So actually I think this is the display data and then this is just display power. Because if we go in here, kind of lift this up, we can see protocol systems incorporated internal interconnect. Failure to install installator sheet will violate patient isolation and create a hazard, blah blah blah, possibly kill somebody, you know, kick puppies on its way home from work, whatever. Who likes puppies anyways? So you can see these really nice clunky switches, just push membrane buttons on the interior, but they've got like metal on them. Just, you know, good old-fashioned over-engineering, and then that is soldered down. Where are my slightly more abusable tweezers? Can't keep track of anything. I bet this just pops in. Yeah. Alright. So, this is 600-0212-01-Rev B. So, fancy pants sheet. So you can see it looks like they have a back plane for the LCD, which takes, you know, these communications and this, and then shoves them into this connector here, which is probably just a standard interface. Snug all screws, then torque to spec in number order. And then you can see there's another giant ass ground plane here. Look at that, plus 107, negative 87, plus 215, plus 12, plus 40, negative 175, plus 20, plus 5. Man, this sucker takes a lot of rails. So that's probably what this whole transformer is for, generating all the various obscure rails they want for this thing. Not exactly low effort parts. And then this connector indeed does just go to the two indicator LEDs. Alright. So now we're looking at the main board. You can see that this is a PCB. It's an ADC31. So this is an 800 series microprocessor. It's probably an ADC31. blah, blah, blah. Intel 1980, wow. Philips 1989, this is fairly old. Over here we have another EDC31BH-2 for 6570. So they're both the same microprocessors. Here's that hilarious HC49 crystal. Let's see if I can't get the rev number sticker off of this. It's probably a PROM. Atmel AT27C512R. 2R. Another one. This is probably exactly the same. Now I really want an EEPROM. This is an AT27C10 C010L. So probably slightly different amounts of memory. This is 433-0344, 433-0334, slightly different part numbers. See the optos, PC900V, PC900V, so these are each going in one direction, and then we just have a 2501. This is interesting. Is that a multi-frequency crystal? I doubt it. But you can see Ceronics, 18.4320 and then 10.7520 megahertz. So I'm not too sure. That might actually just be a dual canned oscillator. And quite interesting is down here, I bet that's the RTC clock, but look at that. It's got like one of the exposed window clock crystals. And then there actually appears to be a guard trace on here. Here's another 47C5 JCT HC4040. So this is just a CMOS logic. HC138A. Big TANs. Look at all of these big ass TANs. These may be TANs, so they could be electrolytics. HC14, HC00, HC08, HC123. This is all 74 in series logic. Here's an N82050 L4202879 74HC393. This is interesting. LT1032CS. I wonder what that is. That may be with linear tech. It could be an ADC. I doubt that. It's probably like a power regulation of some sort. Sharp parts. LH5168N-10L. I bet this is, I mean, considering this, and then this is the HD61830B00. Considering this is proximity to the interconnects for the displays, I bet this is like the display driver, and this could potentially be the SRAM for the display. Something like that. Down here we have another PM7528 HPC, which is kind of around here. This is probably, I'd think that'd be related to the RTC, but I don't know why the battery's way the heck up here when it looks like the crystal's down in this corner. HC373. This is approximate to the microprocessor TC55257 BFL-10L. I bet this is SRAM. Here's a Linear Tech 337485. Here's a Dallas DS1210S. I don't know what that is. I'd guess like RTC related just from the Dallas part number, but I don't know. Here's another 337. I bet these are op amps or something like that. This part here, which is proximate to this great big box here, this is just an LT1070 CT. It's another 5-pin device, and then look at that. That's a cute little chip inductor. And then you've got some heavy-duty ground strapping, diodes and stuff. This is probably all primary side drive for this. And then actually, these great big loops of wire. See if I can't get that info. So this is fairly interesting. So here's this. I mean, look, there's these two sheathed loops of wire that are held onto here with sticky tape. Oh, wait, do those run into the transformer? I don't know. I think those may be additional transformer windings. I'm not entirely certain. Then we've got a big electrolytic, probably reservoir for the switcher. So I don't know what some of this stuff is. It's kind of interesting. This is this device here. It's a multi-comp 129-0185-00, and it's just a big box. If you look on the bottom, it's got 5 pins on each side. So that may be an integrated switcher, though that strikes me as unlikely considering that giant TO220 device right there that seems to be connected up to it. There's a little snap-in insulator. So under this additional insulating sheet we have over here, let me see if I can't push the pin on this out actually. There we go. So there's nothing of interest here, though you can see that this is the footprint for that the EEPROM. So we've got a big, here's this huge kind of ridiculous shield. You push the pins on these out. It's a lot easier when you have access to the other side. And now these should just kind of pull right out. Just have to squeeze the tabs. Pop, 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 pop. And then you can see up here is where it's actually tied in. There's just one little ground lead there. Look at that, they actually knocked holes for component leads. So, man, look at that. Look at how thin this PC board is. That's like very, very fine. And it's only a single layer. The whole thing's just kind of ridiculous. And then one of the other things you can see is that if you look, you can see they've got all these holes here, which line up with these pin headers here. You know, and then you can see they've got the holes, and then they've got the copper pulled back from the holes, so they don't short out or anything. Got another one up here. So that, oh, these are all these connectors. These are the input connectors. Wow, look at that. They've got all sorts of termination stuff going on here. So I didn't see any, like the giant diode assemblies they had in the other one. I didn't see anything like that for protection from for preventing the system from blowing up. So the general consensus is all of the ridiculous diodes on that other system were because, if they want to defib somebody, they're not going to pull the leads. So you have to make sure that defibbing them with the system on doesn't cause the system to blow up or shock them through the system or cause it to start smoking or whatever. So we can see that these metal shielding cans are held on by, they're not soldered on, they're just bent tabs. You can see like they bend the tab. So, I'm just pulling these screws out of the pressure transducer, which are incidentally really snug. They've been thread locked. So, let's see. There we go. Just kind of yoinked the one that was in the solder out of the solder. Let's see. This one has two soldered tabs. Just kind of stick something in there, and then just spread it out after you stick it in the hole. Whoa! Okay, so they appear to be using neons for defib protection. That's interesting. So I guess this is probably the... Okay, so this had one EKG, or ECG, whatever you want to call it. It had one ECG and then two NIBPs, or IBPs. So I bet that the blood pressure ones don't need really strong protection. I wonder, maybe they don't need to be as protected because they could be insulated. They may not be directly connected to the body. They may just, basically run into the body. Seems like I'm kind of assuming that's a bad policy, but I'm not the one regulating this stuff. There's that side. Yoink that one out. Wow, more intriguing bits. So it looks like they're basically just relying on the fact that when you get some serious voltage here, those neons are going to go conducting and shunt it. Yeah, I wonder if they're just relying on the fact that when you get some serious voltage here, these neons are going to go conducting and basically just shunt the current away from your leads. So you can see here we've got, I bet this is the ECG lead input. We've got some HCF 4052s. Not too sure what that is. Here's a 14053B XAA343. This is a 27M4AC TIT122BN. I don't know that. There's a TLO64 op amp. Here's 200 meg resistors. And interestingly enough, look there, you can see that there's guard rings around here, which makes complete sense. Actually, look at all of the interesting, there's all of this guarding in here. Guards there, guard ring, look at that guard trace there, guard trace there. Guard trace there, guard trace here. Wow. Guard trace here. Here's a 1 mic film cap. There is a 27M4 AC again, or a TIT122BN. Here's more TLC40161, TLO64, another op amp. Look at all of these. I don't know what those are. Those are resistors. These are probably precision 1.5K. I bet these are a whole bunch of precision resistors. TLO64. A whole bunch of little, the exact same devices in SOT23 package right next to the pressure transducer, which is what this big black thing is. Really enormous, ridiculous ceramics. Here's some more of those MMAD 1108s, MMAD 1108. Here's a TLC 15411, I think. 1541L or I. HCF 4051. I think that's an analog switch. Lots of TANs. And it's back into the CPU section. So I think I've gone over the 74HCT 377. I don't know what the 377 is. Here's the processor, HC373, HC14, more just general TTL. Look at this, they've got these nice little test points for clipping onto. It's very nice. Minus VD. Hey look, it's all labeled. TXD, minus VD, reset. I bet that's what this is. I bet this is RXD, though I don't see a label here. Plus 15 volts. That's nice of them. There's also another huge row of these here. I wonder if these are clamp diodes. I bet that's what they are. Though I don't know why they'd have a whole bundle of them over here. Strange. See those neons. So I don't know. I would bet that this part here is the ADC, because I don't see any other parts that could be the ADC, unless the ADC is somewhere over here. Here's a TLO64. But I bet the analog digital conversion would be in the can. I bet this is like a fancy, it may be dual slope considering these just ginormous ceramics. 27L9C. Look at this, here's I guess they didn't have enough layers, so they just put a through-hole resistor and they just used that on above some of the surface mount parts. 0000 jumpers. Just the layout, I mean, all of these little guard traces that are wrapped around a lot of these pins. I don't know if they're necessarily guard traces, they just couldn't run it inside. But I mean, you can kind of see this partial guard trace here, and then I guess this is ground and they just ignored the leakage there, or they couldn't fit the trace there and were just willing to accept the leakage loss. Actually, on the other side of the board, you know, same exact thing. Look at the guard traces here. You know, though this is grounded. Guard trace here, guard trace here. Little guard rings here and here and here and here. On the other side of those 1 meg resistors, the same thing. So interestingly enough, I don't know why that's there, because it doesn't appear to be connected. I mean, I'd think it might be connected to that point, but it's not. Weirdness. Some nice, you can see lots of different trace thicknesses, though they didn't use 45-degree angles in here for some reason. You can see that this is a 4-layer board. It's kind of, it's very early, actually 1993, so this this board layout was 1993. It's probably done with really early computer software where, basically doing, sophisticated layout stuff in the computer was a lot of effort, so most of the time they just did rectilinear jogs back and forth, except when they really had to do, well, the hell, why not just go like that? And then, I don't know. It could just be straight up sloppy layout like this, unless they're trying to avoid bringing it under something, just go like that, or, 1K resistors. I don't think this is a bare board anymore. You can see lots of, I'm not sure. It looks like that's a split plane. Look at that. They've got like a single, I think there's a single link there. This is also nice. Look, VS, negative VS, positive VS, negative VR, positive VR. IAG, negative VD, positive VD. So this is probably analog section. Yeah, so this is analog section. This might be isolated analog ground. So it looks like they've got this big ground split here, and then the single jumper point is right there, which isn't under anything of interest. So I don't know. Over here you can see these funky little insert into PCB clips, which went to that flex connector. And up here you can kind of, there's that funky crystal. I've never seen something stood up on edge. Somebody must have hand lead formed that. And then soldered it down. Hadn't seen something like that before. And it looks like they have a whole bundle of test points up here, only some of which actually have clip points in them. So they're all the same footprint. Well, that's interesting. So this is the IAG test point. I bet that is ground. And then these aren't labeled. Interesting board. Definitely interesting. Let's so here is the front panel LCD module, or well, ELD module. It's nicely labeled. Snug all screws. Look there, ground here to test. The test points, like how are you going to test that? It's been tented. I bet there's, look, if you look at the giant ground core on here, and then you can see how it's strapped to the display module, I bet they had EMI issues internally and they had to add a lot of shielding. There's the display. Oh yeah, look at that. So there's the actual display element, and then you can see here the glass is very clearly tinted. I bet this is conductive. Let's see. Huh, wow. So there's, I'm just sticking my test leads on the glass. Look at that. That is 13 ohms. So this glass is very, very conductive. Or it might be polycarbonate. But yeah, I'm from one corner of the glass to the other corner. 29 ohms. And then you can also see that, so I'm just kind of going like this. So between those 2 points, just like that, is 13 ohms. And then this gasket material is also quite conductive. It's 288 ohms from those 2 points. So I bet they had issues with the scan on the EL display getting everywhere else, and possibly even getting into other equipment. So they just had to shield the bejesus out of it. Here's the front panel of the display. See, is this kind of disassemblable? Is that a connector? No, it's connectorized. Okay. Let me see. That little bit comes off. Right. So this one doesn't seem to have any bad lines, so I might hold on to it to try and use it for a project or something. Oh yeah, so I just clip those 2 connections. So here is the actual display, and then you can see in there, you know, you can see the various the rows. I don't see the columns. I don't see how they're driven. I mean, I can see the breakout for them in there. But you can see that, you know, basically the top row connects here, and the next row connects there, so they're every other row. Oh, I see how it works. It's deposited on the glass. See those markings up there? That's deposited straight on the front panel glass. So I think they have like a conductive matrix across the glass for the columns, and then they probably just drive these. Interesting. Here's the back panel here, and then you can see V all on is 214 volts. There's the display, 94 VO. Lots of, I don't know who that logo belongs to, but ASIC's out the posterior. ULC, is that a slash? ULC/XC3030. And here's the interface connector. So Planar Systems Incorporated. So this is indeed it is indeed a planar electroluminescent display. You can also see down here, USA 1991, HP2231. And you've got two big chips down here with a barcode on it. And then lots of big SOT223 devices. Interesting too. MMAD1109, 3082, big resistor arrays. But HV57708PG. So I bet these are specialty ASICs that drive the the various columns or rows directly. It's a very interesting assembly. I'm not going to try and take it apart because I'll probably totally break it. Oh yeah, look, you can see the traces on the glass. So you see those you can barely make it out in the reflection, but you can see the traces for the vertical rows. Interestingly enough, it looks like there's traces on both edges. So this may like the top half and the bottom half of the display may be multiplexed, so they need fewer. I don't know. They may use twice the column drivers and half the row drivers, or vice versa. I'm not too sure. But you can actually see here, that giant ground strap was actually soldered right to there, and then the ground plane on that board and the other one was soldered right to there. And then if we look at this shielding board, you can actually see there are some devices on this side. 14013 HC08A. So here are the ribbon cables. And this is also a 4-layer board, because you can see, I don't know how, otherwise these connections here, how would they get anywhere? Because, basically it's just solid copper here and solid copper there. So all of these signals are running through the internal layers. Then you can also see it looks like there's additional bypassing here. C6. Lots of bypassing. It's a hell of an interesting apparatus. Trippy stuff. Yeah, anyway, so I hope you found that interesting. Not too sure what I'm going to do with all the parts. But I might try and poke around with it, see if I can power something up independently. I mean, I don't think I'm going to get this back together after I had to break those solder joints. But there's another, much more compact patient monitor. That did not go in the trash can.